Hello guys, welcome. In first part we learned what is basic element which takes part in conduction, and that was electron. Today in part 2 we will learn what is semiconductor, how it is made and what are its type and uses. Let us go to the topic. हाँ, इससे पहले आप पार्ट 1 इसको जरूर देखना so that part 2 आपको अच्छे से समझ में आए. Okay? Let's see. So this is semiconductor. It denotes a solid state material whose resistivity lies somewhat between conductor and insulator. So you can say it is neither pure insulator nor conductor. So mostly used semiconductors are silicon and germanium elements. Understand, these are of two types again. One is intrinsic, another one is extrinsic. Intrinsic वो semiconductor है जिसमें कोई impurity ऐड नहीं होती, means it is a pure semiconductor. Extrinsic is the semiconductor in which we add some impurity ताकि हम उसको अपने हिसाब से डिजाइन कर सकें. It should behave as per our requirement. So again, extrinsic semiconductor जो है they are of two types, N type and P type. चलो थोड़ा इसके बारे में सीखते हैं. What is intrinsic semiconductor? Let us understand. जो ये intrinsic semiconductor, let us take a silicon semiconductor. Its atoms are tightly bound with other atom. Its atom, you can say its atom. Suppose two atoms are there. Let us go to the marker. Just let me take the marker. See, suppose this is a piece of semiconductor silicon. Here you have atom. These are the atoms inside this, in this semiconductor, and it is having orbits. Each atom is having orbits. As we know, silicon, the atomic number of silicon is 14. So its outermost orbit there are 4 electrons. As you know, 14 means 2, 8 and 4. So it's outermost orbit there will be 4 electrons, 1, 2 and 3 and 4. So this atom will be tightly bound with this another atom with covalent bond. Let us see how it is. In next slide we will check. See, now see, suppose this is silicon, one piece of silicon semiconductor, and inside there are atoms. These are atoms. So I'll take one atom outside, 2 atoms I'll take outside to make it very clear. So this is the nucleus, this is nucleus, and this is its orbit, let us say, and this is again nucleus, this is orbit. So here we will have 4 electrons. Let us take 4 atoms of silicon. So now you see it is having 4 electrons in its outermost orbit. Here also it will have 4 electrons in its outermost orbit. Here also it will have same 4 electrons. So now see, let us take one more here. It is having again 4. Now see this, I'll take this single atom, how it is bounded with this. This is making covalent bond with this. Now see, this is again making covalent with this, and this is making, take anything, take any 2 electrons. So its 4 electrons are tightly bound with another atom. So now you can say that this silicon is in this way, this is bonded. Now in room temperature. At room temperature, there are very less number of electrons in conduction band as we discussed yesterday, but that is not our requirement. Our requirement is that there should be sufficient number of electrons, free electrons, so that we can use those electrons for our requirement. So how we will get these free electrons? We will add something in this. We will add something in this that is called impurity. So most of the impure so we will not discuss about this. That was a pure semiconductor which was tightly bound with Wu atom. Semiconductors are those N-type and P-type. Here we add some impurity. So this impurity is normally added in ratio 1 ratio 10 to the power 8. If anybody is preparing for some exams, this will be helpful. Means 1 ratio will be impurity and this will be the original semiconductor. Now what is N-type of semiconductor? When we add any pentavalent impurity in this type of semiconductor, so what happens? Let us see. Okay, as I told you, silicon atom is having 4 electrons in its outermost orbit. Let us take one silicon atom. Let us take another one. Let us take another one. So it is having 4 electrons. It is having, and this silicon is also having 4 electrons in its outermost orbit. You understand this? Okay. So here also it will have 4 electrons. I am not making all 4 electrons. You understand? 1 electron is here. So here it will be making covalent bond. Here it is making covalent bond again. Here it is making covalent bond. Here also it is making covalent bond. Now there is no free electron. When we add some impurity, again it will have silicon here, it will have silicon here, it will have silicon here. So all atoms are bound tightly with each other. Now when we add some impurity, here we add antimony as impurity. So what is antimony? It is Sb. This is an element whose atomic number is 51. Its outermost orbit having 5 electrons. So that's why it is called pentavalent impurity. So now when we add this 5 or pentavalent element in it, what happens? Let us go to the slide. Let us go to the slide. थोड़ा slow चल रहा है. Please cooperate. Now see, as I discussed, so this was silicon 1, 2, 3, 4. Here also it is silicon 1, 2, 3, 4. So now antimony was having 5 electrons in its outermost orbit. So 4 electrons made covalent bond with silicon. See, these 4 electrons have made covalent bond with silicon atom. Now 1 electron is extra, which is here. Now it is shown by the arrow. So this is called free electron. It has no one to share with. This is free electron and this will keep roaming inside this semiconductor crystal. Now see, this free electron will take part in conduction. Let us go to the p-type. When we add an impurity which is having 3 electrons in its outermost orbit, that is called trivalent, and it will leave one space vacant for electron. That is called hole in electronics. Here this impurity was having 1 extra electron. Here this impurity is having 1 electron deficiency. This is called hole. If some electron will come here, this will be filled, but from where this electron will be coming, that place becomes hole. Okay. Now let us see. Assume that a small amount of pentavalent element such as antimony is added to the pure silicon. This N type of semiconductor, we make it, and when trivalent semi trivalent element or atom we add it into, that creates P type of semiconductor. Now see, this is called donor atom and this is called acceptor atom because it needs one electron to get valence. Now this positive donor occupy, this positive element which is a donor occupy an energy level very near to the conduction band. Now this electron, this is very loosely bound with this to this atom, very loosely bound to this atom. When some energy is given to this electron or to this atom, this electron jumps from वैलेंस बैंड टू कंडक्शन बैंड, जैसे कि हमने फर्स्ट क्लास में डिस्कस किया था. So it jumps into conduction band and it takes part in conduction. Now mostly used is N type of semiconductor. Let us understand how it works. Now see, when there are more number of electrons, whatever is more, here in N type majority carriers are electrons and here P type majority carriers are hole. Majority carriers, the number of the electrons or hole, whatever is more, that will be called majority carrier. Here in N type of semiconductor, and here is N type, this is N type, here majority carriers are electrons and minorities are holes. Here is P type, majority carriers are hole and minorities are electrons. So when we add these two, N type of semiconductor and P type of semiconductor, it makes one component in electron that is called diode. And this diode we will discuss how it behaves and what is its purpose in our part 3. So guys, यहाँ तक हमने डिस्कस किया what are semiconductors, the types of semiconductor and how they are made. In next class we will discuss what are its uses and how it works in diode and how diode behaves as a switch. Let us keep it surprise for the next session. आप वहाँ पे प्रेस कर सकते हैं if you like the session and subscribe and share and comment. आपको इसमें कुछ कमेंट करना चाहते हैं नेक्स्ट क्लास में हमको क्या लेना चाहिए, विल डेफिनेटली reply your questions. Thank you so much.